3. For the intervention group, was there a statistically significant change in GAF scores from pre to post treatment? How about for the control group? Because we are looking at change within subjects, use a dependent samples t-test. In SPSS, it's called a paired samples t-test. Okay, so here's what we're going to do. We're going to pull up our SPSS again. And again, the question asks whether or not there's a significant change in pre to post for the web CBT group and then also for the control group. Well, we already have selected out our web CBT folks, right? When we, in the last part, we selected those folks out and ignored the control group. So we're just going to leave that in place. So we're only dealing with web CBT. And now what we're going to do is a dependent samples t-test, which is just a little bit different from an independent samples t-test. This is really, we're looking at repeated measures, right, of the GAF, because the GAF was done pre-treatment and then post-treatment. We would hope if the treatment was effective that we would get a statistically significant result. In other words, that global functioning after treatment is better than functioning before treatment for the web CBT group. So I'm going to go into SPSS. I'm going to go to Analyze, and again going under Compare Means, and you'll see one sample t-test, independent samples, and then it comes down here and you see something that says Paired Samples t-test. Now, these dependent t-tests come by different names depending on what programs you're using and so forth, but in SPSS, a dependent samples t-test is called a Paired Samples t-test. So we're going to click on that. And you get kind of a different screen from what you saw before with the independent samples t-test. What we're going to do is pick out our pre-test, which is GAF pre, and I'm just going to click the arrow and that passes it over right here. And it says, okay, variable 1 is GAF pre, and then the other variable we're looking at is GAF post. Okay, so now we have pre and post, and we're only looking at the web CBT folks. And I'm going to look at my options. Again, there's not many options, so we're going to just accept that. Now, the way SPSS is set up, I could run multiple paired samples t-tests. I mean, so I'm just going to run one here, but I could keep adding them in if I want to do a whole bunch at once. It leads to a much bigger printout. But I say, okay, we're pretty much all set. I'm going to click OK, and up comes our printout. And we see for the GAF pre, now keep in mind higher scores on the GAF mean better functioning. So the mean score is 44.06 pre-intervention, and the post score is 50.18. There's your standard deviation, there's your standard error of the mean. Okay. We also know that GAF pre and GAF post scores are correlated 0.88, so there's a very high correlation between the two. But don't interpret that to mean that the GAF post scores are the same as the GAF pre-scores, because a correlation statistic is just a rank order statistic. Basically, it's asking, are the cases rank ordered similarly between GAF pre and GAF post? So if you see changes in the mean, whereas, for example, folks got better as a result of treatment on average, so everybody's score elevated at GAF post, but they stayed in pretty much the same rank order, you're going to still have a very high correlation. Okay, so 0.88 does not mean that the scores between post and pre are the same. It just means that the rank order of cases is very similar. Come down to paired samples t-test. And for this, we don't worry as much about homogeneity of variance, so there is no Levene's test because we're dealing with scores with the same subjects. And for reasons we won't go into, homogeneity of variance is less of an issue when you're dealing with measuring the same folks more than once. So there's a negative score here for the mean difference. It's negative 6.12. Tells us the standard deviation, standard error of the mean. We're going to ignore those for now. Confidence interval, ignore those for now. One of my pet bugs about SPSS is this information, when you're doing an independent samples t-test, is presented on the right side of the printout, but in paired samples t-test, it's presented on the left side of the printout. And so I don't know why there's that sort of inconsistency in the formatting. It just seems a little annoying. Here's what you want to kind of pay attention to is this stuff right here. So our t ratio, our t statistic, is negative 4.93. What that's telling us, because of the negative sign, is that the pre-test scores for GAF were lower than the post-test scores. So negative 4.93. Okay. Now, that's not bad. You know, that's not a bad statistic. In fact, it's getting large enough in magnitude. And the way that you know it's getting large enough in magnitude is that the size of this 4.983 is getting much bigger than the standard error of the mean, right? Which, if we pulled that together, is going to be quite a bit less than the t itself. So when we run the statistics, we get negative 4.983 with 49 degrees of freedom, and then this is going to be significant at the 0.001 level. Anytime you see 0.000, it doesn't mean there's no probability of this event occurring. All it means is that the probability of obtaining this test statistic by chance or measurement error, because of just the inherent variation in the data, the chance of that occurring randomly is less than 1 in 1,000. Okay? So we're going to reject the null hypothesis here. This really seems to be telling us within the Web CBT group that scores improved. They went from 44.06 to 50.18, and that change, that improvement in functioning, was larger than what we could account for by chance or measurement error. Therefore, we're going to conclude that the best explanation we have is that it was the effectiveness of the treatment over time that probably accounts for the difference. We reject the null hypothesis. Now, keep in mind, as a researcher, I'm saying, okay, I rejected the null hypothesis that the means for pre and post GAFs are equal. I reject that null hypothesis. I think the reason for that is because the treatment was effective. Therefore, GAF post scores are drawn from a different population than the GAF pre scores, because the GAF post scores are drawn from a population of individuals who have been treated effectively. But this still provides indirect evidence of the effectiveness of the treatment. It could be, for example, that people just get better from depression over time. And so these GAF pre-scores improve, and it has nothing to do with the treatment. That's one of the reasons we run a control group, because a control group has not been treated with the Web CBT. But this analysis that we're doing right now, just to demonstrate a paired samples t-test, doesn't take into account the control group, right? We just have the Web CBT folks. Okay, so that now we got to write it up, and we're going to write up a significant result, and we'll say, okay, with regard to GAF scores, the Web CBT group showed a statistically significant improvement in scores from pre to post test. And now I put the result in. So T and our degrees of freedom, in this case, there are 50 pairs of data, right? So you have pre and post, 50 subjects, so 50 pairs of data. The degrees of freedom in a paired samples t-test are calculated as n minus 1, so the number of pairs minus 1. So that's going to be 49. And then the t is negative 4.983. I'm going to come back to this in just a second. 4.983. And then you put the probability level in of that occurring by chance or measurement error. And we already discussed that that is 0.001. Okay, so the probability of that occurring is less than 0.001. APA would also like you to put effect sizes in after this. So the size of the effect. We're not going to do that right now. We're just going to focus on the t statistic and the p-value. But just so you know, there would usually come a comma and then a effect size reading right there. I'm going to go ahead and put this in APA format by italicizing the p and the t. Okay, and there you have it. I wrote up the result expressing the result from a paired samples t-test. Now, one of the things you might look at and say, oh, you know what looks kind of weird here is that there was an improvement in scores from pre-test to post-test, but the t-value comes out negative, right? So it almost looks like the scores are going down. So to avoid that, I want to show you something, and that is I could run the test again and go to compare means and paired samples t-test, and this time I'm going to put the GAF post-test scores in first and the pre-test scores. And then I run the analysis again, up comes my result. Now keep in mind, the first time we ran it was negative 4.983. Look what happens when I just reverse those two. Okay, it reports what I did the first time, GAF pre, then post, and then it goes GAF post, then pre. All that happens in the result here is that the sign flips. Okay, so I can go back here with justification and say, look, let's just get rid of this. Okay, say 4.98. It's the same thing. Okay, and that by not putting the negative sign in, it just looks a little bit better. Okay, and it's completely accurate. Okay, so our results section is coming along nicely. We have very turgid, concise, tight writing. That's what I like to see you do. Don't copy my writing when you do yours. Think of other concise ways of saying the same thing. But let's move on to the next question.